So we have two different libraries for us to work on, for us to train neural networks. One is neural net. The neural net, you can specify as many hidden layers as you want. Okay, so like here we have two hidden layers. So hidden equal to C, and the number of neurons in each layer. Okay. And but when you use the neural net with the Caret library for control, neural net will only handle regression methods. In other words, it won't do classification for you. It will only do numerical target. It won't do classification target. And for classification target with Caret, you have to use NNet. Okay. We did NNet example last time. The restriction or the limitation for NNet is you can have only one hidden layer in NNet. So you need to just simply specify what the size is, and then the learning parameter. Decay is the learning parameter. Okay, so we can train the model, okay, using Caret. So this is you set that seed one. There are two things that you can specify for any model, so neural network or decision tree or whatever. Sometimes you need only one, sometimes you need both. And now we're going to look at only one. Okay, so that is, we want to try, okay, for the hidden layer, we want different sizes and different decay values for it to try training. Okay, so let's call this my grid. And we have what is called expand grid, okay, that is part of base. Now you can specify the parameters that is relevant to the model. Okay, so this is a common code. You can use this in any method, right? So if it is regression, then you want to specify how many variables to use, how many predictors to use, then you can specify that here. In KNN, you can specify K here, like K list. Okay. But here, for NNet, there are two parameters that we have to specify. One is called dot size, okay, and size is your number of neurons in the hidden layer. So we want 5, 6, and 7. Okay. And then we have dot decay. Okay, so that's the syntax. And say we want to try two different learning parameters, say 0.1 and 0.5. Okay. Now if you run this code, you see that a data frame is constructed for all combinations of size and decay. So you'll have for each size 5, 6, and 7. So decay value of 0.1, 5, 6, 7, decay value of 0.5. So we have three possible values for size, two possible values for decay. So there are 6 combinations. So by this my.grid, what we are saying is, okay, these are the 6 different parameters for which we want to run the model and train the model. Okay. So then we'll call this ACCNN3, train. Okay. And okay, so as factor max severity IR. Okay. Well, you have to specify the formula here. Say so everything. Okay. And then okay, let's see where the data is. Okay, train.df. Okay, so train.df has all the converted columns and the target. So that's what we have to use here. So train.df. Okay. So this simply says what is the target and what are the predictors. Okay. And then we have to say the method. Okay. So here is where you specify whatever method you want. In this case, it is net. Okay. And then we can say tune grid. Okay. Tune grid. Okay. Equal to that my grid. So this part of the code says to train and run this model for each combination that we have set up. So it will run, take the values from my grid and repeat the training 6 times. Okay. All right. So now we are not specifying any metric. Okay. So the metric, the default metric is accuracy. Okay. But if you wanted to use some other metric, then you have to specify. Okay. If you want to use ROC, if you use ROC, then that will use the area under the curve as the metric. But for that to happen, then you have to set up control and make sure that those probabilities are properly computed. But instead of accuracy, you want something else. Say, for example, so let's look at okay, ACCNN to out. No, not that. Well, we don't have. Well, see, the confusion matrix will generate lots of output. So you can choose one of those other output as your metric if you want. Okay, I'll show you in just a second. So let's do this, and then I'm going to use trace equal to false. Save ourselves some. Okay, my grid. Okay, so neural network, because it is computationally intensive, so some of these procedures will take a little bit of time. So ACC.NN3, okay. So here if you look at best tune, tells you what the best tune is. Okay. 5 for size, 0.5 for decay. Okay. It tried through all of this, and then line 4 is the best that it found. Okay. And then what is the metric that it used? Okay, so accuracy is the default. It will show you that. Okay, let's see. Where is it? Okay, here it is, metric. It says accuracies. Now, if you don't want accuracy, okay, if you want to use something else, so here we have kappa. Kappa is a modified version of accuracy. Okay, if you wanted kappa, then you can say kappa here. You know, add one more line, one more parameter, say metric equal to kappa, and so now kappa will be used as the choice. Okay, so there are two different levels going on here. One is the method itself, and then what are the parameters you want to feed, and how many repetitions you want to apply with that model, and how do you select the best. So that's what caret does. Caret is something sitting on top of the method and running the method the way in which you specify caret. So if you go back now and if you look at see the metric now is kappa, all right, and then the best tune, you get the same best tune, okay, and so on. So now we have the best selected, then we can use that best selected to do the prediction. So if you do ACC, okay, let's do it in a separate chunk. Okay, ACC NN3 pred. Okay. In neural, if you use neural network, it's going to give you only the output. Then you have to do the which max to figure out which class the prediction is. Whereas NNet will give you the prediction by itself. So you say predict, and you use this model object ACC.NN3. So it is selected of those 6 different parameters. It is selected one, which we already saw, and then you say valid.df. So that will give you the prediction, and if you want probability, then use the same model object with the data, valid data, and then you say type equal to prob. Okay. Sometimes some models require the keyword needed for probability is sometimes different for different methods. So sometimes it is response, or some, I wish they were all the same across the board, but sometimes it's not. And it'll tell you though, if you make a mistake, it'll tell you, okay, this has to be this, then you can make the correction. Okay. So now you see ACC NN3. Okay. So we have the probability for the 3 classes. Okay. And then ACC NN3. What is that? ACC NN3 pred. So that must be here. So here it is, the predictions. So these are classes are predicted, 0, 1, or 2. Okay. So once you have the predictions, you can run confusion matrix from that. And if you want ROC chart, you can use this probability to develop your ROC chart.